Hi guys, today I'm going to show you how to calculate the binomial distribution. So how do we know we use the binomial distribution to calculate this question? Well, it's because it satisfies the four conditions needed to execute the Bernoulli trial. Condition number one, there must be a fixed number of trials. And in this case, there is a fixed number of trials because there is a total of 6 shots. N must always be a fixed number. Condition number two, there are only two possible outcomes, either success or failure. Either the basketball player shoots and scores, or the basketball player shoots and misses. There are only two possible outcomes, success and failure. Condition number three, the trials are independent of each other. And the fourth condition is the probability of success remains constant. That means if the basketball player shoots and scores on the first throw, it doesn't change the probability of the basketball scoring on the second throw. So the probability of success and failure remains the same. And in this case, the probability of success is 60% and the probability of failure is 40%. So in other words, the basketball player has a 60% chance of scoring and a 40% chance of missing. So now that we know it is a binomial distribution question, let's get started and do it. So let's get started and fill in what we know. We know that there is a total of 6 trials, or in this case, there are 6 attempts on the basket. We also know that the required number of successes is 4 because we're looking for the probability that the basketball player will score 4 attempts out of 6 shots. So or must therefore be equal to 4. Now P stands for success, and the probability that the basketball player will score is 60%, and therefore the probability the basketball player will miss is 40%. And notice that the probabilities, both P for success and Q for failure, must always equal 1. So now that we have noted the formula and filled in our values, let's get started. The circles indicate the number of shots, and there are 6 shots on the basket. We are looking for the probability that the basketball player will score 4 of the 6 shots. And for simplicity, the shots the basketball player has scored are marked in green. Remember, the formation doesn't matter. In this case, we have scored 4 consecutive shots, but it could be score, miss, etc. It really doesn't matter. As long as the basketball player scores 4 shots out of 6 throws. So now let's break it down. N is 6, or is 4. So that means 6 choose 4. There's a 60% chance of the basketball scoring. So 0.6 to the power of 4. And we put it to the power of 4 because we're looking for 4 successful shots. There's also a possibility the basketball player will miss. And that's 40%, or 0.4. And we put that to the power of 2 because we're looking for the probability that he will miss 2 shots from 6. Remember that the powers, when added together, must equal n. 4 plus 2 equals 6. And the answer is 0.31104, or 31%. So this means there's a 31% chance this particular basketball player will score 4 and miss 2 in 6 throws. This question is also binomial because it satisfies our 4 conditions. However, it's slightly more challenging. So now that we've noted our formula, let's get started. The circles here again indicate the number of throws. We know the basketball player has taken 5 throws. We know that the basketball player scores for the second time on the 5th shot. So that essentially means that in the first 4 shots, she scored once, and in the last, or the 5th shot, she also scored. So that essentially means that the basketball player scored 1 shot out of her first 4 shots. So here you see it. In the first 4 shots, she scored once, and in the 5th shot, she scored her second. So we need to break this question up. Let's calculate the probability that she will score 1 shot out of 4, and then we'll calculate the 5th shot. So as you can see, n now is 4, and we're looking for the required success, which is 1. The probability remains constant. The basketball player has a 60% chance of scoring and a 40% chance of missing. So now that we have our formula and noted our values, let's get started. So we'll work with the 4 shots first, and then later we'll consider the probability of the 5th shot. This means that there's a 15% chance of this particular basketball player scoring 1 shot from 4 throws. However, we also need her to score on the 5th throw. And because this is a standalone event, the probability remains the same, 60%. So we multiply 0.1536 by 0.6, or 60%. So the answer is 9.2%. And the reason we multiply 0.1536 by 0.6 is because this is the probability that she will score 1 shot from 4 attempts. And the probability that she will score on the 5th shot, when treated independently, remains at 0.6%. And we multiply them because we need her to score 1 from 4 and on the 5th shot. And in probability implies multiply. And therefore, the probability that the basketball player will score for the second time on her 5th shot is 9.2%. If this video helped you understand binomial distribution, don't forget to like and subscribe.